Hey GED students, it's GED question of the daytime. And again, we're talking about a topic that normally stumps a lot of GED students. We get so confused about fractions, just really confused because it's hard to think about a number that can have so many equivalent forms. Equivalent meaning equal, meaning different fractions, even though they can look very, very different, could actually be equivalent, equal to each other. And that's weird to think about. And how could that even be? When the numbers are different, how could the fractions be equivalent? Well, fractions are not about the individual numbers. They're about the relationship between the numerator, the top number, and the denominator, the bottom number. So they don't have to have the same numbers to be equivalent. They have to have the same relationship. We call that being in proportion. Okay, there's a couple different ways to check if fractions are equivalent. I'm first going to do it the cool math way, but this only works if you remember it. And then I'm going to do it another more maybe intuitive way. It doesn't matter which way you do it, okay, guys? Sometimes my students get mad at me when I teach them more than one way to do something, but it's super important to know more than one way. I'm screwing stuff up right now as we speak. Let's see if I can fix it. So, like I said, it's super important to know more than one way to do things because just like when you're out in the world, sometimes the best tool is a hammer, sometimes the best tool is a screwdriver. Depends what you're doing. So let's take a look at two different ways to prove fractions to be equivalent. First way, you could know this relationship. There's a relationship between equivalent fractions. As it turns out, mathematicians remember that equivalent fractions, and again, I mean when they have equal value, they're equal to each other, have cross products. You're like, what is a cross product? A cross product is when you multiply in a cross shape. I'll show you what I mean. So they have cross products. Products means to multiply that are equal. What am I saying? I'm saying that if I multiply in like a crisscross fashion, the numerator of the one fraction times the denominator of the other, and then I compare it to the other cross product, the numerator of the other fraction compared to the denominator of the other fraction, they had better be equal. So let's give it a try. Let's try the numerator of the first fraction times the denominator of the other. 24 times 15 is, I think it's 360, but I'm feeling a little slow today, so let's verify it in our calculator. It's 360. Now let's compare that to the other cross product, the other fraction's numerator times the other fraction's denominator. So let's try 10 times 36. And again, I get 360. And because I see that cross products are equal, because the two cross products that I got are equal, I got 360 for one, I got 360 for the other, I know that these two fractions are actually equivalent. Now you might be saying, Kate, I will never remember that in a million years. How am I supposed to remember that cross products are equal? Fine. You know, there's more than one way to think about things mathematically. If that sounds challenging for you to remember, then here's another thing you can always do. You can always reduce fractions. Because if fractions are equivalent, they're going to reduce to the same lowest terms. If they're equivalent, and that's why we reduce things to lowest terms. That's the whole reason why we reduce fractions to lowest terms. So that we can see, we can all have a common way that we all agree on to talk about a fraction. If we all just have our final answers in lowest terms, we can all go, oh, we were all talking about the same number all along, even though they looked different. So if fractions are equivalent, they will reduce to be the same exact identical fraction. Not just equivalent, but identical. Same numerator, same denominator. So let's try reducing each one of these fractions. This, although it's not the way that most mathematicians would go, is the way I would expect a lot of GED students to go, because this is more intuitive to us, okay? So when you reduce fractions, you just find any factor they have in common and you divide it out. So looking at the numerator, 24, and the denominator 36, do they have any common factors? Now you might be saying, Kate, I don't know. I'm not good at my times tables. Well, even if you're bad at your times tables, you ought to be able to see that both those numbers are even. All even numbers are divisible by 2. You should at least be able to do that. So 2 goes into 24 12 times, and 2 goes into 36. Let's see, 2 goes into 3 once, remainder 1. 2 goes into 16 8 times. And once again, that's my little plug for sight division. I was using sight division right there, so I didn't have to use long division. Okay, and now I can see 12 and 18 still have something in common. I happen to know they're both on the 6 times tables. I'll divide a 6 out of both of them. 12 divided by 6 is 2. 18 divided by 6 is 3. The only common factor of 2 and 3, the only number that will divide them both evenly, is the number 1. And like I always say with fractions, 1 and done. Once you get to 1, you're done. So this is reduced to thirds. Let's take a look at the fraction 10 and 15. Once again, I see common factors. The common factor between 10 and 15 is screaming at me, because I notice that both of those numbers end in 0 and 5. I know that's just how my 5 times tables behave. I'm going to divide a 5 out of both of these numbers. 10 divided by 5 is 2. 15 divided by 5 is 3. And take a look at the two reduced fractions. 24 36ths and 10 15ths may not have looked equivalent, but they are, because they share the exact same relationship. For every 2 numbers in the numerator, there are 3 in the denominator. I'm going to say that again. For every 2 things in the numerator, there are 3 in the denominator. The relationship they share is 2/3. They're both equivalent to 2/3. That would be another way to prove fractions equivalent. So are the fractions below equivalent no matter which way I go? Of course, because good math always works. I came up with the answer yes. Okay, stay tuned. We're going to do a couple more like this in the coming days so that you can see this skill a few times. If you have any questions about this or any other GED topic, be sure to drop it in the comments. I'll do my very best to answer it.